Hey everyone, and welcome back to this class, Artificial Intelligence, Reinforcement Learning in Python. In this lecture, we're going to talk about how we're going to represent states in our tic-tac-toe game. Earlier, I promised you that this would be an O of 1 lookup. One way to accomplish this would be to use a dictionary, since the keys to a dictionary can be any immutable object. So we could represent the game board with a 2D tuple of size 3 by 3 and store the values inside as tuple elements. However, we can do this so that each state maps to a number, and by doing that we can store the value function as a numpy array. So how can we map each state to a number? Recall that we talked about how to find an upper limit on the number of states earlier. We calculated it to be 3 to the power 9, or 19,683, which is not too big of an array to store in memory. Notice that this also encodes impossible states, for example, an X in all 9 locations, since you only need 3 in a row to win. This overhead doesn't affect the algorithm at all, so we won't worry about it. These states are never reachable anyway, since in every iteration of the loop, we're going to check if the game is over, and if it is, we'll quit the loop. So these values never show up in the state history, which means their values will never be used or updated. The idea of having 9 locations and 3 possible values per location should remind you of binary numbers. You know that n bits can store 2 to the power n different integers, and we can enumerate those possibilities by finding all the permutations of a string of length n, where each location can only contain 0 or 1. To convert a binary number into decimal, you know that the equation can be represented like this. So all you need to do is replace the 2 with a 3. Instead of b representing only 0 or 1, it'll have the values 0, 1, or 2. In code, it's going to look like this. Notice how we loop through each location on the board, which requires a nested for loop, but that's only because of the structure of the board. We need to keep track of the power, which starts at 3 to the power 0 and gets multiplied by 3 on each new location, so we keep track of that with the variable k. We use the variable h to accumulate the final result. We use the letter h because h stands for hash, and that's essentially what we're doing. We're hashing an object and the output is an integer.